Hello! This second video is all about still verifying whether the set of eigenvalues and eigenvectors are fit for the given 2 by 2 matrix. So to do this, we are going to use a specific process to be satisfied rather, and if the said process is satisfied, then we have guaranteed that the corresponding eigenvalues and eigenvectors fit for the identified matrix. The process here is simply multiplying your matrix A by your chosen vector. Let's just say, let's pick the first pair here, x sub 1. The result of this should be able to achieve the product of multiplying the said eigenvalue and its corresponding eigenvector. If we could satisfy this, then that's the process or the verification that this is true. So for the first one here, my bad. Of course, we're using x sub 1. So x sub 1 here. So to satisfy this, of course, our A is 4, -5 to -3 to be multiplied with our x sub 1, which is 1 and 1. The result of this should be able to represent a result of multiplying your lambda sub 1 and x sub 1. Let's find out. Of course, when you multiply matrices, this is a 2 by 2 matrix to be multiplied by 2 by 1. So the resulting form is also 2 by 1. And don't forget the process. 4 times 1 is 4. -5 times 1 is -5. 4 times plus -5 is -1. Second, 2 times 1 is +2. -3 times 1 is -3. That's also -1 here. This is the result of A times x sub 1, our vector. Okay? So, this also should be thicker because this is a vector, right? Okay, let's make this thicker. Anyway, this result now can be factored with -1, and what remains on our matrix is 1 and 1. Why we chose -1? Because that's the goal. We need to show that the lambda sub 1, the eigenvalue, once factored out on our result, could return or together with its corresponding eigenvector. Of course, this is our lambda sub 1, and what remains here is also our x sub 1. This is now verified. This pair of eigenvalue and eigenvector is now satisfied. Again, this should be thicker because this is x sub 1. Now let's do the same thing for the second set. So you have your result here or process A, 4, -5 to -3 to be multiplied with your second vector. That's 5 and 2. The result of this should be able to represent the product of your second eigenvalue together with its corresponding eigenvector x sub 2, which is again thicker. Hopefully that's already okay. So let's continue with the process. Same thing, 2 by 2 times 2 by 1. So 4 times 5 is 20. 5 times -5 rather times 2 is -10. 20 minus 10, you have +10. Next, 2 times 5 is 10. You have -3 times 2 is -6. That's +4. This is the result when multiplying A by your second eigenvector. And since our second eigenvalue is 2, so if we're going to factor out 2, let's find out if this would be the vector. So dividing that, of course, that's 5, that's 2. Noticeably, this is our second eigenvalue together with its corresponding second eigenvector. This has been satisfied as well. So do the same thing for the next set, bottom. So let's use the spaces here. So we need to satisfy A, x sub 1 here. Okay, so this would be A is -2, 4, 1, and 1. To be multiplied with your first vector here, 1 and 1, and again, this should be represented by your lambda sub 1 times your x sub 1. So when we multiply this, you have negative 2 times 1 is negative 2, 4 times 1 is positive 4, that's positive 2. 1 times 1 here is 1, 1 times 1 is also 1, 1 plus 1, that's 2. Look at our first lambda, it's 2. So when we factor a scalar of 2, we have here 1 and 1, and that's our second vector as well. We have here, first vector in this case. So you have your lambda sub 1, and this was your first vector sub 1. So this has been satisfied, and we have verified this already. To finish, your x sub 2 here, x sub 2. So you have negative 2, 4, 1, and 1. Okay, so this should be multiplied by negative 4 and 1. That's our x sub 2 here. And this should return to lambda sub 2 times your x sub 2 thicker. So we have here negative 2 times negative 4. That's positive 8. 4 times 1 is positive 4. So positive 2 and positive 8 and positive 4, that's positive 12, right? Next, you'll have 1 times negative 4 is negative 4, 1 times 1 is 1, negative 4 plus 1 is negative 3. This is the result now. And if we're going to factor this, negative 3, let's see if this could be achieved. Of course, negative 12 divided by negative 3 is negative 4, and negative 3 is positive 1. This was our lambda sub 2, and this corresponds to its assigned eigenvector, and this has also been satisfied. So this is again how we verify the pair of eigenvalue and eigenvector for a specific 2x2 matrix. We are going to, let's review here, show that the product of a matrix and the said eigenvector should result or can be represented by a product of its corresponding eigenvalue times the corresponding eigenvector. Okay, and we have satisfied both sets of eigenvalues and eigenvectors for these two set A's. So thank you very much for watching.